Okay, so here's another one on distinguishing chemical and physical changes, and you'll see why we needed, I think, a second video. So again, 4 sketches below, substance X changes, 3 changes, right? The changes, it might be impossible, it might be a physical change, it might be a chemical change. So look what I got here. 2 red balls, 2 red spheres, okay? Well, those are typically oxygen, by the way. Red is typically used to represent oxygen. So let's say that this is 2 oxygen atoms that are bonded together. This is O2. This is what you breathe. But it's organized. Look how organized it is. So it's probably solid. This is a solid oxygen. And can you see that this is made of red spheres? This is also made of red spheres. So it's definitely possible, right? It's a 1-to-1. It's not even a 1-to-1 ratio. It's just there's only one thing there. So this is definitely possible. And it looks like they have the same connectivity, right? The same bondedness. So this is O2 and this is O2 also. So it's not a chemical change, but look at the arrangement is different. See how these guys are ordered with respect to each other? And these guys are not. They're changed. They're moved around, right? So that's going to be a physical change. I can't click it. I forgot. That's a physical change. We didn't see a physical change in the last video, so I wanted to do this one. All right, now look at this second one here. You see it looks like I've got 2 red spheres for each molecule, and here I've got 3. So it's definitely a different bondedness, right? I think these pictures are drawn such that if you count up these balls, you have the same number of balls down here. Let's do it. 1, 2, 3, 4, 5, 6. So there's 6 in each row. 6 times 4 is 24. 1, 2, 3. Okay. 1, 2, 3, 4, 5, 6, 7, 8 times 3 is 24 also. All right, so yeah, these atoms, it looks like there's the same number of atoms as you have here, right? So, but they have different connectedness. So this is a chemical change, right? Because you're changing bonds. So that makes a chemical change. And here now, we've introduced a new kind of atom, which we know is impossible, all right? I mean, outside a nuclear reaction, it's impossible. And even so, this would take, I don't even know what that would take. But that black is typically represents carbon. And so if this was carbon and that was oxygen, this would be carbon monoxide. And you're not going to get carbon monoxide from oxygen gas. You're not going to get that. So look at that. This is impossible, right? So again, this is a different arrangement as we have, but the same molecules. So it's a physical change. These are different molecules, so it must have had a chemical change. And this is different atoms. You can't get carbon if all you start out with is oxygen. So this is impossible. All right, hope that's helpful.